To prove this identity, we're going to use a different little technique, which is I'm going to try to make the right side equal the left side. And if you notice in the denominator, we have secant of beta minus tangent of beta, which almost looks like one of our Pythagorean identities, but it's not because it doesn't have the squared terms. So I'm going to complete that square by multiplying by the conjugate of the denominator. We're going to multiply by secant beta plus tangent of beta. And whatever we do in the denominator, we have to do the same thing in the numerator so that it stays equivalent. So now, in our numerator, we have the cotangent of beta times secant beta plus tangent beta. But in the denominator, we've created a difference of squares. So when we multiply this together, we're going to end up with secant squared minus tangent squared. So our numerator stays the same, cotangent of beta times secant of beta plus tangent of beta. But our denominator is now a Pythagorean identity, and secant squared minus tangent squared is equal to 1. So now we can just work with the numerator. Let's distribute the cotangent of beta to both terms, and we'll have the cotangent of beta times the secant of beta plus the cotangent of beta times the tangent of beta. Cotangent is equal to cosine over sine. That's a quotient identity. Secant is equal to 1 over cosine. That's a reciprocal identity. And then cotangent and tangent are reciprocals, so when you multiply those together, you get 1. Our first term, we have a common factor of cosine that will divide out. So we're left with 1 over sine plus 1, but 1 over sine is the cosecant because it's reciprocal. So we have made our right side look like our left side and proved the identity.